On this Silverado 2500 with the 6.6 diesel, P0128 means the engine coolant temperature is being judged below the thermostat regulating temperature. In plain terms, the truck may not be warming the way the control module expects, or the temperature signal may not be believable. You may see cooling fans come on, and a service emission or exhaust fluid message can show up with this fault. Keep the broad fault areas in mind: coolant level or condition, thermostat operation, temperature sensor inputs, the signal and low reference circuits, and only after the circuit checks prove out the engine control module. Start with the basic system checks, keep the diagnosis structured, and do not chase P0128 in isolation if other temperature-related sensor codes are present. The engine coolant temperature sensor is a negative temperature coefficient thermistor. As temperature goes up, sensor resistance goes down, and that changes the voltage on the signal circuit. The control module input circuit has an internal resistance connected to 5 volts, and the low reference is grounded through the control module. For normal scan tool data, use an idling engine at normal operating temperature. The ECT parameter normal range is 88 to 105 degrees Celsius, 190 to 221 degrees Fahrenheit. Typical fault pattern data shows the signal circuit at 150 degrees Celsius, 302 degrees Fahrenheit, for a short to ground, open at negative 40 degrees Celsius, negative 40 Fahrenheit, and short to voltage at negative 40 degrees Celsius, negative 40 Fahrenheit. On the low reference side, an open or a short to voltage also shows negative 40 degrees Celsius, negative 40 Fahrenheit. Be careful with any short to be positive, because internal control module or component damage may occur. For P0128, the monitor gates include startup ECT equals negative 40 to 50 degrees Celsius, negative 40 to 122 degrees Fahrenheit. Engine coolant thermostat heater command equals less than 20% for greater than 5 seconds. Engine off time equals greater than 30 minutes, and engine run time equals 20 seconds to 25 minutes. The code sets when engine coolant temperature is not within a calibrated range, so treat those gates as the conditions needed to evaluate the fault, not as a parts call. The first actual check is coolant level and coolant condition. If the level or condition is wrong, correct that before going any deeper. If the coolant check passes, look for codes tied to the coolant temperature and intake air temperature sensing. If those are present, check what they mean first. One useful sanity check is a cold soak comparison. Intake air temperature and engine coolant temperature should be within 3 degrees Celsius, 5 degrees Fahrenheit of each other if the ignition has been off for greater than 8 hours. Also remember that high resistance in the related circuits may set P0128 without setting a separate component code. Now run the engine for greater than 15 minutes with the air conditioning off, and slowly increase engine speed to 3000 RPM. Watch the scan tool ECT sensor parameter. It needs to be warmer than 80 degrees Celsius, 176 Fahrenheit. If it is not warmer than 80 degrees Celsius, 176 Fahrenheit, the diagnostic outcome is engine coolant thermostat replacement. If it is warmer than 80 degrees Celsius, 176 Fahrenheit, operate the vehicle within the monitor gates, or under the captured conditions from the fault data, and verify P0128 does not reset. If the code does not reset, the result is all okay. If it does reset, move into circuit and sensor testing. For circuit testing, turn the ignition and vehicle systems off before disconnecting connectors. It may take up to 2 minutes for all vehicle systems to power down before an accurate ground or low reference continuity test can be made. Disconnect the B34 engine coolant temperature sensor. Test between low reference circuit terminal 1 and ground for less than 10 ohms. If it is 10 ohms or greater, disconnect the appropriate K20 engine control module connector and test the low reference circuit end-to-end for less than 2 ohms. If that end-to-end test is 2 ohms or greater, repair the open or high resistance in the circuit. If it is less than 2 ohms, the diagnostic outcome is K20 engine control module replacement. If the first low reference to ground test is less than 10 ohms, turn the ignition on with the vehicle in service mode. With the coolant temperature sensor disconnected, the scan tool ECT sensor parameter should be colder than negative 39 degrees Celsius, negative 38 degrees Fahrenheit. If it reads negative 39 degrees Celsius, negative 38 degrees Fahrenheit or warmer, turn the ignition and vehicle off, disconnect the appropriate K20 engine control module connector, and test signal circuit terminal 2 at the component harness to ground for infinite resistance. If you have less than infinite resistance, repair the short to ground on the signal circuit. If resistance is infinite, the diagnostic outcome is K20 engine control module replacement. If the disconnected sensor reading is colder than -39 degrees Celsius, -38 degrees Fahrenheit, connect a 3 amp fused jumper wire between signal circuit terminal 2 and low reference circuit terminal 1. The scan tool ECT sensor parameter should now be warmer than 149 degrees Celsius, 300 degrees Fahrenheit. If it is warmer than 149 degrees Celsius, 300 degrees Fahrenheit, test or replace the B34 engine coolant temperature sensor. If it is 149 degrees Celsius, 300 degrees Fahrenheit or colder, turn the ignition and vehicle off, remove the jumper wire, disconnect the appropriate K20 engine control module connector, then turn the ignition on with the vehicle in service mode and test signal circuit terminal 2 at the component harness to ground for less than 1 volt. If it is 1 volt or greater, repair the short to voltage on the signal circuit. If it is less than 1 volt, turn the ignition and vehicle off and test the signal circuit end-to-end for less than 2 ohms. If that test is 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms, the diagnostic outcome is K20 engine control module replacement. For component testing, turn the ignition and vehicle off and disconnect the B34 engine coolant temperature sensor. Test resistance between signal terminal 2 and low reference terminal 1. The broad check is 42 to 78,834 ohms. If it's not between 42 and 78,834 ohms, replace the B34 engine coolant temperature sensor. If it's between 42 and 78,834 ohms, compare the value to the correct temperature versus resistance data for that sensor. If the value is not in the specified range, replace the sensor. If it is in range, test for infinite resistance between each sensor terminal and the sensor housing. Less than infinite resistance means replace the sensor. Infinite resistance means all okay. If you do not have the exact temperature versus resistance values at that branch, pause and do not guess the sensor call. After the repair is complete, verify the repair and confirm P0128 stays gone. Keep that verification separate from the category-specific testing you just performed. If the service emission system or service exhaust fluid system message is displayed, perform the reductant system tamper warning service bay test only under that condition. That procedure clears the applicable driver information message. The takeaway is simple. Prove the engine reaches the required temperature first, then prove the ECT signal and low reference circuits before condemning a module or sensor. For more diagnostic training, visit stepdiagnostics.com.